Section 4.1, radian and degree measure. Starting with some terminology that you're going to need to be familiar with. An angle in standard position has an initial side and a terminal side. The initial side of an angle is always along the positive x-axis. The terminal side is where the angle ends up when we begin rotating from that initial side. So if I have, let's say, a 120 degree angle, I rotate 120 degrees. Our terminal side now is right there. Coterminal angles are angles that share the same terminal side. So this 120 degree angles, coterminal angles are always going to be differ by one full revolution, and you should know that one full revolution is 360 degrees, which means that a 480 degree angle is going to be coterminal with 120. Likewise, I could subtract 360 from that 120, and negative 240 degrees could be coterminal. There are infinitely many angles that are coterminal with any given angle because we can continually add 360 or subtract 360 from an angle to find another angle that is coterminal. Complementary angles. Two angles whose sum is 90 degrees. Supplementary angles. Two angles whose sum is 180 degrees. Degree and radian measure. Most of you should be very comfortable with working with degree measure. It's the measure, angle unit measure that you have used in geometry. You know what a 90 degree angle looks like. You know what a 180 degree angle looks like. You know that there are 360 degrees in a circle and so on. You need to become just as familiar with radian measures because we are going to be using radian measures quite a bit in the next two chapters. 0 degrees is 0 radians. Pi over 2 is 90 degrees. Pi radians is 180 degrees. 3 pi over 2 is 270. And 2 pi is 360 degrees. So when we look at the coordinate plane, when we look at this circle, we know that this is 0 degrees, this is 90 degrees, 180 degrees, 270 degrees, and all the way back around is 360 degrees. In radians, we have pi over 2, pi, 3 pi over 2, and 2 pi. How do we know then whether an angle measure is given in degrees or radians? Well, the whole key is how is it labeled? If there is no degree symbol on your angle, it is assumed to then be in radians. So if you give an answer and you intend that answer to be read as degrees, you better make sure that you have a degree symbol on it. Otherwise, I am going to assume that it is a radian measure that you are given. So make sure you're paying attention to the labels on the angle so you know whether it's in radians or degrees. Our conversion factor. To convert from degrees to radians, your conversion factor, we know that there are 180 degrees in pi radians. So if we want to go 2 radians, we want radians in the top, degrees in the bottom. If we want to go the other direction and we want to convert 2 degrees, now we're going to put the degrees in the top and the radians in the bottom. So our conversion factor is the fact that 180 degrees equals pi radians. Depending on what you are converting to is going to tell you whether it's going to be pi over 180 or 180 over pi. Find the complement and supplement of each angle. I'm actually going to start over here with the degree one. So you're going to be more comfortable with that. So let's go and find the complement. Complementary angles, we know add up to 90 degrees. So if I want to find the complement, I'm simply going to subtract from 90. And our complementary angle is 30 degrees. If we want to find the supplement, supplementary angles add up to 180. So I'm simply going to subtract from 180. There's the supplement. Again, make sure you have a degree measure on those final answers. When we're dealing with radian measures, we do the same type of thing. Complement. Well, we know complementary angles add up to 90 degrees. In terms of radians, that means they add up to pi over 2. So instead of subtracting from 90 degrees, I'm going to subtract from pi over 2. Now we do have to do some fraction work here. Get a common denominator. 5 pi over 10 minus 2 pi over 10. There's our complement. Supplement, do the same type of thing. Supplementary angles, we know add up to 180 degrees, which is pi radians. So I'm going to subtract from pi. Again, we need to get a common denominator. And we get 4 pi over 5. Find two coterminal angles, one positive and one negative. Once again, I'm going to start with our degree measure here. Well, I know if I want to find a coterminal angle with this angle, that I can add 360 degrees to it. We get 590 degrees. I could also subtract 360 degrees, and we get negative 130 degrees. Radians, same type of thing, but now we need to understand how many radians are in one complete circle. Instead of 360 degrees, we're talking about 2 pi radians. So I'm taking this, and I'm going to add 2 pi, get a common denominator. Add those together, we get 13 pi over 6. There's our positive angle. Do the same thing now, but we're going to subtract 2 pi. Negative 11 pi over 6. Conversions. Convert 2 degrees. Well, we're starting with radian measures, that tells us. The reason we would know that if it didn't is because there is no degree symbol. To go from radians 2 degrees, we want to convert 2 degrees, so our degrees needs to be in the top, radians in the bottom. Simplify that expression. Pi's are going to cancel. 6 goes into 180 30 times. 30 times 5 leaves us with 150 degrees when we simplify that expression. Do not get confused. A lot of students look at this and think it has to be a degree measure because there's not a pi involved. Okay, pi does not necessarily have to be involved in a radian measure. This is 7 radians. I want to convert it to degrees, so that's 180 over pi. We multiply straight across. We get 1260 over pi degrees. There's our exact solution. If we plug that into the calculator, take 1260 divided by pi, it's approximately 401.07 degrees. Finally, the last one, converting the other way. Now we're going from degrees to radians. So I have 120 degrees. I'm converting 2 radians. So now I want the pi in the top, the degrees in the bottom, so the degrees cancel. 120 over 180 simplifies to 2/3. So I have 2 pi over 3. Negative 315 degrees going 2 radians. So pi radians in the top, 180 degrees in the bottom. Simplify that expression, negative 7 pi over 4.